Hello and welcome to Beyond the Horizon. It isn't just me. You'll be pleased to hear Dr. Alex, for those who for some reason wouldn't know who it is who stumbled onto this stream by accident, having no idea what's going on, which coincidentally is exactly the frame of mind we are all in here too. So yes, this is obviously the live stream that followed the episode of Beyond the Horizon we just watched, which was on parallel universes and M theory. And as I say, I'm not on my own. I do have the ever reliable and amazingly valued help of old media guy. So now watch me seamlessly leap towards the laptop and back in the usual way I do.
Hello.
Hello. I'm going to assume that everyone could hear me when I did that. And it wasn't just miming to camera absolutely silent, yeah?
Oh, yeah, we can hear you.
Because I don't know, because when I removed myself from the stream and then put myself back in, it was making all sorts of dire warnings about the fact my audio had been cut off and will it ever come back again? But it did.
Yep, you're good. We can hear you.
Brilliant. I've just realised I've left my phone, which is how I monitor the chat, in the other room. Could you juggle for 2 seconds while I go grab it?
Sure,
Awesome.
I can do that.
Old media guy's juggling is second to none. Observe.
Well, during the Beyond the Horizon live stream, Dr. Alex plugged his book, several books, in fact, season 12 and season 13, and I have them on my shelf. And
he's showing them to you right now. You may not be able to see this.
I don't have it on video, but they're on my shelf right now. There's even a gap left for 14 once it's published.
Yes, that will be so exciting when it's done. But we really shouldn't be talking about the Doctor Who stuff in the middle of a live stream about very good old science documentaries, which is what we've been watching.
Yes, it was very interesting. I had no idea that the people in this field actually know what they're talking about. We're talking about the possibility of creating a baby universe in a lab.
Yes.
That to me is it's like, are you sure this isn't the Avengers? Because it sounds like the Avengers, and it weirds me out when PhDs talk about doing this. Because science fiction, that's fine. When you're doing it in the lab with a government grant, I don't know.
I know. I mean, I know. I am curious as to how far they got into actually realizing this in a real. I know they've done it on paper, but did they do it? And I should go away and look. I really should go away and look it up. It can't be that hard. It's not like they hide this stuff. I can find it.
Yes,
But yeah,
it'd be interesting to know how much energy it would take to do that.
Okay, I just said we should not talk about Doctor Who when we're talking about all this stuff to do with actual physics or actual physics plus string theory.
But now that we have a PhD saying they might be able to create a universe in a lab, it's not science fiction anymore.
No, but you might remember in the final episode, I'm not going to say too much for spoilers, of the Doctor season 12, where the Doctor created, actually the first Doctor had already made a pocket universe for his cupboard, his closet. And he obviously put Bessie in there and was driving around in it with Clara in this universe, which, slight spoilers, does nub off from our universe in the end. So
is that another plug?
Well, no. That was actually me saying, this is where I got the inspiration from. There are several things. This episode has always stuck with me. I mean, I guess I said it all in the episode itself, but this inspired me to go back and start studying astrophysics again. And then, because that worked out so well, it inspired me to go out and actually do the PhD. So this has always stuck with me, this episode. And it's been a continual inspiration in my life, including bits of it still leached into the Doctor stuff I've been writing.
It's interesting you say that, because I had a similar experience with a film, which I'm probably going to forget the name, Stand and Deliver. The film with Edward James Olmos as Jaime Escalante, the public school teacher from LA.
Yeah.
Now, the movie, pedagogically speaking, is trash. I'm not trashing the movie. I'm just saying what they show you in the movie is impossible. And Jaime Escalante himself said, what you see in the movie cannot possibly happen. Let's take one group of kids who are in 9th or 10th grade basic math and get them to do high school or above high school algebra in 3 years. It's just not possible. But what he did was do that over many, many years. So he started out with kids who had no hope of understanding calculus, and next thing you knew, he was producing more students than the authorities said he should, i.e. there was cheating going on when there wasn't.
No,
But watching
absolutely.
that made me realize, oh, so there's not an insurmountable barrier to learning calculus. This is just something in my head where I'm afraid of it.
Mm.
And maybe if I took another look at it, I would do fine. And then flash forward a few years and I have a master's in math. So
Yeah,
we have
exactly.
similar
It's
experiences in that regard.
very similar experience. I mean, I never thought, even though I always loved the idea of understanding the universe and cosmology, I never thought I'd become essentially, or at least adjacent to, a theoretical physicist of all things, because I really was doing badly earlier on in my physics career and barely got my degree. And I was saved from not get from failing my degree by the practical stuff at the end. So my practical experiments and stuff in my second or third year just dragged my marks up enough to get me through. I thought I'd never be doing high-end maths and a theoretical leaning. No, never seen a piece of equipment in the entirety of my PhD. That was not what I expected, and yet it was kind of where I always wanted to be in some part of me, I guess. But
Yes, that was very much my attitude towards math. I knew very much I wanted to learn more about what was going on.
mm,
And I had no way to get there early on just because of
yeah,
the situation I was in. And that included me making a whole lot of mistakes.
oh, me too, me too.
Yeah. Those stories that we wrote in our early 20s about drinking a lot, yeah, I probably could have skipped that.
Uh-huh. Yeah, definitely. Um, it's funny how I really wasn't drinking very much before I started the PhD. The drinking level went up quite a bit, and I blame my supervisor for that.
Mm.
But I was still way more mature in dealing with it than I was when I was an undergraduate. That's for sure. I
Yes, yes,
really was
that's
stupid at the
exactly
time.
it.
Yeah.
The master's program did not drive me to drink, but I did wake up in the middle of the night wondering if I was experiencing a heart attack, and it turns out it was just stress.
Mm. Oh God,
Yeah,
yeah. I have
yeah.
scars. There are scars from spots on my forehead, which are not from my teens. They're from my mid 30s when I did the masters. I must have been leaning on my forehead so much that I actually caused spots, bad spots, to erupt across my forehead.
Mm.
I literally have the scars of my masters because it was that stressful.
Yes, but I would like to add for anyone who's listening, it was not the topic that was the problem, it was the teacher.
Ooh.
And if you have a teacher who is genuinely not teaching, I don't mean you don't like their style or they don't like you personally, but I mean if they are just not teaching because of
Mm.
whatever is happening in their lives, you have to bring it up with somebody in the department. And if
Hmm.
they brush you off, you've got to keep taking it up the chain of command until you get to somebody who will listen, even if that means, and this is a last resort, calling the local news media and saying, I got a story for you.
Yeah, yeah. No, you do. Yes, you. If there are problems in the academic department you're in at whichever level, yes, you need to deal with it. I'm not going to say any names, but there was a
No.
problem in my masters. Ultimately, it led to my PhD, where how I got to the supervisor I got for my PhD. But we had a really inspirational cosmology lecturer for my masters, but I'd spotted, because I was already working in education before. I knew how this worked. I knew how teaching, marking, all of that stuff worked, and when it didn't work, and what the causes were. And very early on, I saw that he wasn't getting our problem sheets marked and back with feedback after about the first two or three. And I already twigged, because of my prior experience that many of my colleagues didn't have, there's a problem here with this teacher. Call him teacher in this
Mhm.
context. And so I looked around at who else was a cosmologist in the department that we'd actually seen lecture us and was competent. And my supervisor had been given the crappiest course, really. It was research methods. That was it. It was a half course unit of how you do research. And it was like, he obviously, it was very sarcastic and dry and hated it, thought it was a complete waste of time doing it. But he was incredibly diligent at getting it done anyway. And I looked and saw, oh, he's a cosmologist. So I went to ask him to become my supervisor for my master's dissertation. And he was very good at guiding me, making sure I got that done, and I actually got the highest I could possibly get in that dissertation and my master's ultimately. And it was then him that I, a year later, successfully applied to become a PhD student for, and he took me on. But the point of this is that brilliant cosmology lecturer, who might have been the natural conduit to get into cosmology, was not the way to go. And thank God I had prior experience of this kind of problem, and I
Yes.
was able to sidestep that, because yeah, I know that other students fell foul.
Yes. Yes, there's always some professor who thinks just because I'm getting a divorce, I can still teach.
Mm-hmm.
No, you can't. Um, Sad to say, if you, and that's what I don't blame the teacher for that so
No.
much as the department because they refuse to look at the problem. And that
Yes.
was just the attitude of the chair, which is if you bring me a problem, I will deny it. Did I mention the chair was a citizen of the former Soviet Union for many years?
No, you didn't.
So, yeah, so he wasn't too interested in democracy in action,
We have
which in
two.
some ways is a good thing. You don't want 20 graduate teaching assistants marching in the office and demanding changes because that's a recipe for chaos. But
Yeah.
he took it so far that if there was a legitimate problem, he wouldn't listen.
Yeah.
So I don't know
Um,
what this has to do with your documentary, but boy, we're having a good time here.
yeah, this is suddenly gone into the problems of academia. But yeah, what? So at the moment, I can see there are two people in the chat, and nobody said a word. One of them is probably me. Are we actually? Because I'm so bad at this. On YouTube, are we live?
You know, I don't actually have YouTube up because it's such a distraction to me.
I do on my phone, but I'm getting to the point where I'm doubting my own sanity here. That the phone is playing back what we're doing. Surely it must be live, but there's a lot less response than usual.
Weirdly, we should have a goes wrong stream. That's how we get lots and lots of viewers. Like, what's going on this time? Oh, they're not talking to each other. Oh, they hate each other? No, no, one of them can't hear the other, and the other one can't speak to the other.
Right, we should do that, but that should be on your channel because you're the one who does the goes wrong theatre. So I mean, it really it should be you.
Could be. They have such great stunts on that show. Yes, I'm looking at the live stream now, and it's definitely going on. You're shrugging your shoulders and
Hey, Luke's there.
hey, Luke.
Luke Favak, the
Bonsoir.
awesome. Oh, and there's Cam's Crash Courses.
Hey, Cam.
Brilliant. Thank you for letting us know we're not alone. Awesome. Okay, so now don't forget you can make suggestions and throw things to the chat. If anything in that video made you curious, now would be the time to ask because for once, and a very rare instance, I suspect, in the whole series that will generate from this, there's one expert-ish here, and another one who's not that far off an expert. He knows maths. He knows maths well. I'm pointing the wrong way. He knows math well. In fact, that's what I was going to throw you under the bus. So I have no idea what Michael Duff was talking about when he's talking about quaternions and octernions. What are they?
Sure. So let's back up just a little bit. We have what is called the real number system. And that is anytime you pull out a measuring rod of any kind and say, my bookshelf is this big and I've got this much space along the wall, that is the real number system.
Yeah.
Now, you might think it's a little weird, but the fact is that just using those numbers, you cannot measure everything adequately.
That's
not
why
everything.
I thought sorry, I'm one little tiny.
Yeah.
That's why I thought it's related to multidimensionality. Carry on. I remember now.
Okay. So you need more numbers than just the numbers we use to measure stuff in normal four-dimensional space and time. It sounds like science fiction, but it's absolutely true. You have some basic questions in mathematics, such as what is the square root of -1? If you say there's no answer to that question, you're dealing with the real numbers. You're back to your measuring rods. You're back to how much space you've got in the trunk of your car. Sorry, the boot of your car.
I got it. I can.
Okay. Now, if you want to measure electricity, you actually need to define what the square root of -1 is because you cannot solve certain differential equations regarding electricity without it. And without solving those equations, you can't get your laptop to work, your phone to work, et cetera, et cetera, et cetera. So it's a number we need, even though it's not obvious. It's not obvious until we have electricity or other phenomena that requires a definition of what the square root of -1 is. And often that is just called I. It was called I because it was called the imaginary number, because I believe it was the 16th or 17th century where someone said, well, let's just pretend there was an answer and call it I. Let's see what happens. And for a while, nothing happened. And then people realized, no, quite a lot is happening, because suddenly the numbers that you think will act just like all the other numbers ever used, suddenly things act very, very differently indeed. For example, if you have I as the square root of -1, suddenly it's a lot easier to, uh, say, do the math for radar. So we've all seen the images of screens where you have the light, a straight line of light moving around in a circle and little dots appear. And, oh, that means it's a flock of birds or that's planes or whatever it is. Well, using I with the real numbers in what's called the complex number system, um, that makes that sort of calculation much easier. You only need 2 dimensions to figure out where something is on that plane, on that imaginary flat surface. Okay, so you might say, well, there it is. We have this one weird number. We probably don't need any more, right? Well, that's where you're wrong. If you extend the complex number system so that you have I, J, and K, that is 3 weird numbers acting in ways you don't quite expect, you have, with some bells and whistles, you have the quaternion system.
Brilliant.
Which is a non-commutative algebra. Non-commutative being this. Imagine you have to get somewhere by car. You can take a certain road to the place you're going and the same road back when you're done. That's commutivity. Commutivity, I can speak today. So that's a commutative algebra. You can take the same route back as you took to get there. A non-commutative algebra is like taking the bus. To get there, you may take the 13 and then board the 20, but on the way back, you just need the 22. So the journey back is not the same as the journey to the location. Well, that's what happens with quaternions. They go in a direction. It's not oddball. If you look up the Wikipedia article, as I'm doing now, you will see that it's very organized what's happening. In fact, it turns out to be a very efficient way to map movement in the 3 space. And since computer games now have long since moved from 2D to 3D, having quaternions can be very, very helpful. Now, there are other number systems which go ahead and expand this even further. The octonion and sedenion, which I have not worked with at all, they are out there as well. But it gets down to what problem do you need to solve for the cosmologists, for the physicists, and so on. And you only need certain tools. I'm sorry, go ahead.
Sorry, the octonion stuff, you've now reminded me a bit about Duff's lectures, and I can remember him drawing, I guess, they look like 3-dimensional representations on a 2D plane, but it's not, because it's an octonion is an 8-dimensional descriptor. But the pathways was important. Is like, how do I get from here to here through these 8 mathematical dimensions? And the non-commutativity of it as well is ringing bells. I don't know this stuff, but at least you've given me a flashback to some of the things I've watched in the lectures, and I can now, oh yeah, it's really complex numbers would be a good way of putting it.
Yes, complex numbers on steroids.
Yeah.
And it just depends what you need to map. For example, there is a mathematical discipline called topology. And the best way to describe that is, can you get there from here? And there are certain spaces that seem very odd, and actually a bone of contention between physicists and mathematicians is physicists will say, oh, you mathematicians coming up with tool sets that no one will use. And then 50 years later, they use them because they need them. That happened in topology. They had these weird spaces where just about anybody who's sane would say, well, we'll never need those in the real world. Turns out you need them at the quantum level because of how energy travels. So it just depends on the problem you're dealing with and what seems to be happening, what you can observe, and then asking, is there an existing mathematical model that can deal with this? Not only just what we see at the moment, but the changes from one state to another. And that determines whether you need a ring or a group, or you need an entire algebra, et cetera, et cetera, et cetera.
You reminded me of the quantum mechanics that I completely dodged doing, but the Bra and Ket notation for the interactions and the non-commutativity of certain interactions also is not exactly divorced from this mathematics either. It's all bound up in it. And I am very bad at quantum mechanics because I've avoided doing the courses I should have done several times. But I do remember touching on those early stages of the notation for quantum mechanical interactions. And I was sent to that conference 4 times in a row. I kind of, by osmosis, had to absorb some of that quantum mechanical stuff. So yeah, you're reminding me of a great deal right now, in the shaky, shady way that I remember things.
Yes, that's about where I am with quaternions, because it's been a long time since I looked at them. I've not looked at any of their extensions, but watching that it's very fascinating, because it made me think of a number of different topics related to what they were talking about that I haven't had an opportunity to look at for a number of years. So it was a lot of fun. I'm
You
still
mean the
frightened by what they were talking about, though.
Do you mean the quaternion stuff or the stuff in the video we watched?
Well, see, when you watch it, you're looking at something that's related to your field, and it's going to bring associations to the different research you've done, the different people you've talked to, and such. I'll have a similar reaction, except I'm not so interested in the problem itself, not like you would be. I'd be asking myself, well, what math are they using to get there? And is the math they are using the correct tool? Which was exactly the problem that the 10-dimensional people were having with the 11-dimensional people. It was an argument over tool set. It was like two mechanics stopping and arguing about whether they should use metric or imperial wrenches. I mean, that's what it was.
Yeah.
And the documentary was very right to say that physics and many other areas of academia are ruled by fashions and fads, which is why in the chat I said science proceeds one funeral at a time.
Yes.
Because sometimes you just need the old guard to die off before you can say, you know what? This argument about tools doesn't make a lot of sense, because I've done the work and it's pretty clear that this tool set over here is better, and here's why. And because that one person has now died, sadly, others will listen. So yeah, that can happen. It's one of the things I like the least about science is how many people you have to wait to retire before you can get a new idea to be be listened to.
Yes, I always felt for Michael Duff from that video. You could tell how isolated he'd been relative to a lot of the people in the field, and it just seems so unjust. Also, that Ed Witten gets huge amounts of credit for 11-dimensional string theory, yeah, and yet Duff had. I've looked at the paper dates. Duff had been doing his 11-dimensional Sugra stuff before, only a year or two before, or even 6 months sometimes. But his papers are up before Witten, and yet all the 11-dimensional stuff credit gets dumped on Ed Witten, and he's a nice guy and he did great work. But Duff did do this stuff before, but it does make me wonder how different Sugra and 11-dimensional string theory are. There must be other differences, otherwise you would have just said they were the same.
Yes, and of course the question is about the model, and all models are wrong. It's just that some of them are useful.
Yes.
So an 11-dimensional model works better than a 10. The question is, someday will they require 12? Who knows? I mean, I have not looked at the math, but maybe 12 isn't enough. Maybe you need 16. Maybe you need to be working in sedenions. Who knows? Or not.
Because you reminded me of the other thing we really should talk about is that me too in the chat. How huge?
Yes, Luke has just he's posted 2 comments that are very interesting. I'll let you read them.
Yeah, yes, I agree. Researchers really need to understand of the huge role traditions play in their field. Yeah, just as they do in every other role.
Yep.
Yes, I got it. Yeah, I agree, Luke. And what linked to that is we don't. This video really promoted heavily that somehow string theory is the solution, is the next big step. But what we've had string theory from actually the late 60s when it first popped up, but we've had superstring theory for decades now, and we still, as physicists, wouldn't say this is the solution. We wouldn't say, yeah, we've solved it. That's now our multidimensional theory for various reasons. I mean, for example, I did all my work using 4 dimensions. Seems to work. Our universe seems to be 4-dimensional from all the observations we can make. So maybe we don't even need those 11 and 12-dimensional models, although I bet we do need something like that because we know that we haven't got the whole story. But we definitely do not know that string theory is right, or M theory, or supergravity.
Right. Yes, I have a problem in science in that we have a number of popular theories that do not predict anything in a quantitative sense.
Hmm.
And it's been happening so long that if you say, hey, this very popular theory over there that most of science seems to rely on doesn't predict anything, they look at you and say, you're a loony, get out of here.
Mm.
Boy, that drives me nuts because science is advertised as the one place where that won't happen, and yet it does.
To be fair, in the actual field itself, in the academic institution where the cosmologists were on one floor and the string theorists were on the floor above, we did take the piss out of the string theorists because my supervisor regularly say, "Well, we actually only need 4 dimensions to do our work," which is true. And the other thing we take piss out of, well, you will tell us when you've given us a prediction we can actually test, yeah, because they
Yes.
couldn't they couldn't generate. That's the thing that really was skirted over in this video because they were too friendly to string theory. Is that string theory makes no predictions that you can test, makes new
Yes.
predictions. So we have good models for describing our 4D universe. Quantum mechanics and general relativity do a great job of describing it, making predictions which have subsequently been shown to be true. For example, the most obvious recent one would be gravitational waves. We have a prediction from GR, general relativity, and recently we made observations that really said that's heavily likely to be the story. Still
Right.
can't be the whole story, but that works. We have a prediction by Einstein. We've had an observation, shows it, bears it out.
Yeah.
String theories. I say that because there's a massive string theory landscape of different versions of string theory, but they can match what we've already observed, but they don't make new predictions, at least not ones that can be detected in our 4-dimensional universe,
Yes. And
which is
that's
a huge
and
problem.
that's as a mathematician that bothers me because we don't do that in math. You don't publish a paper and go, well, I think it's true. You either have a proof or you don't, and it's a proof that other people can check on archive.
Yeah.
And if enough people look at it and say, I don't see any problems, then it's probably true. Now, we may not know if that leads us anywhere in the physical world
Yes.
for 50 years, maybe 100. God only knows, considering some of the math that's coming out now,
Hmm.
especially with hyperreal numbers and such, where you can't even describe in real numbers what the result is. But maybe it will. Who knows?
I think they can prove it in the way you want. Actually, they probably can show mathematically that what they've said is justified. Justified, but a mathematical justification isn't necessarily a physical world justification because it doesn't always match across exactly as you'd expect.
Yes, they
It
might. They
might,
might be able to show it's a consistent system,
yeah,
but in the end, you ought to be able to predict something of value.
yes. So problem one is they should be able to produce something that they should be able to make a prediction that would be touching our 4D universe with something that our current models do not have.
Right.
That's one
Right.
just one observable alone would be enough to make them much more a physical theory and much less a mathematical playground.
Yeah, I completely agree. Mathematics is wonderful because you can set up a game with rules, and whatever happens next, presuming there's no mistakes, must be true.
Yeah,
And sometimes those games, these models, have application to the real world.
yeah,
Sometimes. We just can't guarantee that everything a mathematician comes up with will have an instant use. But physics is supposed to be about what we observe and see and interact with, even on levels that are so small that it requires millions of dollars just to take a look. So if you've got a
yes.
big theory that doesn't explain anything, I would have to ask why. And I have to ask
It-
that why twice in science. And I don't get any answers from the mainstream people. That always bothers me.
yes. You've actually touched on the other problem with string theory, which I very briefly talked about in the video, which is there are many what we call free parameters in string theory, which is things you can change and it'll change the structure of the universe it generates. How about that? A multi-dimensional universe, as it may be, an 11-dimensional universe, but if you tweak the parameters, it will change the shape of it. And they talked about it very, very briefly in the video that the string landscape has something like 10 to the power of 300 different possible flavors because it has. That's a stupid number. That is just how many free parameters there are in the theory. So you tweak it, you get a different answer. So the fact that they can tweak their theory and give something that looks like the universe we currently observe is not a big surprise because you just tweak the parameters until you get a universe like ours popping out. But as you
Right.
can probably guess, there is almost certainly more than one tweak set that will give you something that matches our universe. And if you've got a theory that you can tweak and generate anything with, are you making any predictions at all?
Yes, that's exactly the problem I have with certain popular theories within science, that they don't predict enough quantitatively for an outsider to come in and say, yes, this makes sense. Instead, we're kind of battered over the head with, you have to believe this. And that's why you get people pulling away from science. And then recently we get the flat earth movement, where people have pulled as far away from science as they can get because they feel like they're outsiders and aren't allowed in because their questions aren't answered. Now, sometimes their questions are bad. They're people. But sometimes their questions are good and they're laughed at, and that doesn't help, and so on and so on. I think it goes back to people getting careers based on stuff that doesn't do anything. Their work doesn't accomplish anything. That happens all the time in English, and I can say that because I've spent a lot of time in English departments. Sociology departments get a lot of flack for that. I'm not sure if it's deserved or not. I haven't been there. But math generally doesn't, and physics didn't until string theory came along. Correct me if I'm wrong.
Well, there's, like I say, there was an entire floor of string theorists above us. There's definitely careers to be made in string theory, but yes, are they generating anything we can test? Not yet. And that's their saving. That's their one get out of jail free card. The not yet aspect. They might be able to generate observables with their theory, but bloody hell, they've had it for decades now, and they haven't yet.
Right.
So we should definitely be cautious at most, weekly as possible. We should be cautious about putting too much store or too much faith exactly, because it's almost like a religion right now, because you can't test it.
Yes.
In string theory, yes. That is the big problem with string. The big problem with string theory is it predicts too much and not enough. So nothing.
Well, yeah, if once it predicts everything, it predicts nothing, which is exactly the problem we have with Darwin's formulation of evolution. And I'm trying to cut Darwin slack here. He's not a 20th century scientist, and he's certainly not 21st century. He was 19th.
Yes.
And the problem is not really with him. It's where people have taken it and said, no, really, this is the way to understand life on Earth. And anyone who says otherwise is an idiot. It's right to ask, okay, so this idea that you're pushing onto us and telling we have to accept or else, what does it predict quantitatively? And they'll say, well, genetically. I said, no, that's genetics. Genetics is completely different from what you're talking about. Genetics is how a dog creates another dog. You're talking about how a dog turns into something that looks like a humanoid. Right. How does that happen? Show me the money. And they can't. And maybe I'm asking too much, and maybe my question is so silly that the people with PhDs are going, no, you've got the question all wrong. But that goes back to my other point, that the rest of us should be able to ask questions. And if we're asking honestly, then the question should be answered as best we can. And as far as I know, no one in the field, I could be wrong, can predict anything with evolution quantitatively. My first reaction to that, if it's true, is not to say, let's get rid of biologists and evolutionary theory. It's to say, why are we funding people who can't do that? And I would do the same with the string theorists.
Well, I'll flip it back at you. Is the purpose of evolutionary theory to make a prediction, or is it to explain what we've got already?
Well, that's the thing. If it's just to explain what we have already, then isn't it just a creation myth? And I use myth in its broadest and grandest sense, not as I'm not trying to insult anyone by using that word there. If it's a creation myth, similar to what we see in the Upanishad and what we see in the Quran and the Bible, et cetera, then why is it being taught as science? Now, obviously, my questions should be dealt with by people who are much more informed than me.
And me, not me. I'm not an evolutionary scientist at all.
Yeah, and so I'm willing to admit the possibility I'm completely, utterly, and tragically wrong, but that's fine. I still get to ask the questions.
However, I bet there are some things you can predict now, because there are examples of convergent evolution that they've dug up from the fossil record multiple times.
I don't buy the fossil evidence, because the fossil evidence was good in the 19th century. It was inadequate as soon as we understood DNA and were able to take samples from the fossils. And we need to find a way to show how the DNA from this creature is related to the DNA from that creature, other than they were 50 feet apart in the fossil record.
That's not the avenue I'm going to go down. I'm trying to give them some slack here because I don't know enough about their field. But the one thing I can give a little bit of information about is that they can probably tell which environmental factors drove a species to be a certain shape if we go through the multiple times a dolphin shape.
Gotcha. Yes, that's fascinating. Yes.
A
I
dolphin
love
shape
that.
has arisen over the years, or even a crocodilian shape has arisen over the years. There must be certain niche, and they do seem to fit into certain niches. So certain niches do seem to heavily favor certain body plans.
Yes.
That's a prediction that arguably is something they could predict. So if you get
Yeah.
conditions where things have changed to this kind of environment, we're likely to get something like this popping up in the evolution record at some point. So there you go. I've given you one tiny example where they might be able to make a prediction.
That's fine with me. I am not looking to trash any part of science. I just want my questions answered.
Well,
And
I
Luke
know, but I had to give him something.
Yeah.
I had to do something.
and Luke has got two more comments you might wish to read, Dr. Alex.
Oh my God. Luke. Pourquoi? Not so much explanations of flexible narrative design to. Okay, yeah, so he's talking about the working backwards descriptive type thing. String theory seems the same kind of mythology of thing of mathematical language instead. Yeah, I mean that's rewording of what I was saying, that they are the tuning thing I was talking about is basically make their theory fit the observations we already have. It's not necessarily then generating new or predictions of observations that we could test, which is back into. I agree, Luke. We're back to the same problem. They are yet so far not able to make predictions that we can test. They do, I think, make weird predictions within their 11-dimensional framework, but then you can't test those other dimensional things they're predicting that have no visible or no measurable effects on the 4D one we're sitting in right now. Because even if we are a 4D universe, which we are a 4D universe, as a bubble in an 11-dimensional hole, if something in your theory has given a prediction about something that's observable only in the other in the other 7 dimensions, well, we can't access those. So well done for making a prediction. We can't check. So again, it's the same problem. You need to make a prediction that will give us something we can check in our 4D bubble, please.
Yeah. I remember being taught the theory of science way back in the 80s. And the thing I remember most is the statement that there is life in other galaxies is not a scientific statement because it cannot be tested. And that's what bothers me when we have a number of different academic departments, inside science and outside science, who are basically saying things that cannot be tested in any measurable way. Or even in the case of certain career fields, if you question these conclusions, you must be the enemy of humanity.
Yeah.
I'm not going to say which ones they are. Women's studies.
If I can bring things back to me, because I'm most important thing.
Oh, absolutely, sure.
No, but you made me think about what we do in science in terms of predictions. So the latter 2/3 of my PhD thesis was testing a model of interacting dark energy and dark matter that hadn't been fully explored yet. I mean, it was an extension of a pre-existing model. I was working with Nelson Nunes, who was the guy who put forward a couple of quintessence where you have dark energy and dark matter that interact with each other. Now we don't know if they do that because we haven't identified what they are, but we can still suppose if they do interact, what observables would that generate? And that's exactly the opposite of string theory. It's like, well, you're taking these things and what would it look like, and will it match what we can see? So that is kind of what we'd expect to have from a good theory. So I was using multi-field coupled quintessence or interacting dark energy and dark matter. In this case, you could have any number of fields, but we went with the basic 2 dark energy species and 2 dark matter species and allowed them to interact. And I basically looked at the strength of coupling between those species of dark energy and dark matter, and depending on how you change the strength of the coupling, would the observed universe you get be within current observations, and would they be detectable in the next set of observations that would come out with post-Planck? So Planck is the satellite we're dealing with now, and I can't remember what the one that was. Well, there were several actual surveys coming up that would give better data of the perturbation side, the lumps and bumps we have in our universe, the voids and perturbations, what we've got. and also the evolution of dark of the expansion of the universe, the accelerated expansion. But anyway, all of those things. This was basically trying to make prediction, trying to constrain how much coupling you could have between dark energy and dark matter species. So it might not sound that exciting, but we were trying to put constraints on what you could put in your theory. So,
Mm.
which we did. We said you can't have coupling between species greater than these amounts if you want to match current observations, but you could have couplings less than these amounts and be within, and then you could see if they matched future observations better than the standard model of cosmology, which is dark energy plus cold dark matter and nothing interacting with anything. Did you
That's
get that?
interesting.
That
Yeah.
was me blathering really bad.
No, that's good. I like that. It's putting a limit on what it. You're putting a boundary on something, and putting a boundary on something, in this sense, means you're trying to eliminate chaos. Chaos is we have no idea what's going on. We have no idea when it's going on, or what's nothing. We know nothing. It's the worst type of existence to imagine. The
Yeah,
good boundaries are the ones that allow you to actually exist and then thrive and so on, which is why if you look at the small housing unit projects here in America, where they move people off the streets into very, very tiny houses for 3 months to get them ready to move into an apartment, that's exactly the kind of boundaries I'm talking about. So if you're living on the street, every moment's about survival. There is no grand future tomorrow to prepare for. But once they
mm,
get them into tiny houses and they get them used to the idea that they're going to have meals 3 times a day, suddenly their flight responses, they slowly go down. They can start to think about, well, what could I do next week? Something you could not ask yourself if you're worried that every second your shopping cart full of stuff will be taken away.
yeah,
And that's kind of in my own perhaps slightly disorganized mind, it sounds like what you are attempting to do there, which is to say there's all these possibilities, but some just aren't going to be there for you. These are the ones
yes,
you got to look for. And if this is true, this is what you'll see tomorrow. There it is. That should be what science is. This
yeah.
is what you will see tomorrow. Stay away from this other stuff because it's just not going to work. But keep going in that direction. Here's what you ought to see. And if that's true, we keep the theory. If not, we throw it out.
Yeah. It's funny because we have no idea what dark energy and dark matter is, but it's kind of nice to say, well, they can't. Well, we kind of define dark matter as not interacting with anything we normally deal with anyway, um, in most models for it anyway. And dark energy only really has an accelerating massive energy. It's the majority of the energy in our universe, but its only real appreciable effect seems to be driving the accelerated expansion of the universe on very large scales. So it's in fact really, really small amounts of energy if you get down to what's in my room right now. How much of my room is dark energy? Basically, nearly nothing. Would be the best answer I could give. But on the huge scales of our universe, that amount of energy is enough to cause massive effects because it builds up. Anyway, but I
So
don't know where I was going.
maybe
Yes,
the
go on.
gravity isn't leaking into the 11th dimension. Maybe it's leaking into the dark energy.
Yeah, exactly. None of the theories I'm talking about actually depend on anything more than four dimensions as well. We don't need. We haven't. Uh, we have explanations that don't require a multidimensional universe. Now, I know it's not complete because I know that quantum mechanics and general relativity don't work together. Something else must be an overarching theory above them.
Hmm.
But it doesn't have to be string theory. It doesn't have to be M theory. It doesn't have to be any of those things, no matter how beautiful the maths may be.
That is true. And since we're on the subject, I want to ask what is it about dark matter that makes it dark matter? So
Uh,
you're
yeah.
sitting on a couch. It's not
Hmm.
dark matter. So why isn't there dark matter on the planet, in your room, on the moon? What is it about it that makes it so exotic? Do we have
There
any
could
data
be.
about that?
It probably, whatever it is, it probably is around us because we know it's local enough to be affect how galaxies rotate. So, I mean, that's from my perspective really small scale. I mean, because cosmology is much bigger scale than that. But
Mm.
galaxy rotation curves work, we assume, because of dark matter. In fact, we see clumping of galaxies and galaxy clusters affected by the dark matter content. We kind of can map. We have mapped dark matter by using lensing, for example, gravitational lensing. We can see the effects of dark matter. We know it's there. We just have no idea what it is, and it's dark because gravitationally is the only way it seems to interact with ordinary matter. So yeah, we could be swimming in dark matter right now, and light isn't going to get absorbed by it. It's not going to get emitted by it. Light won't be emitted by it. It won't have a magnetic or an electric effect. There's no electric fields, no magnetic fields coming off it. There's nothing of the normal fields that we use to interact with stuff. The reason I'm not falling through my couch is because of electrostatic repulsion. Well, dark matter doesn't care about that, so I couldn't make my couch out of dark matter. Let's put it that way.
It sounds okay. This is going to show my ignorance. It sounds as if it's made of nothing but neutrons.
Well, neutrons still. Let's get this right. Neutrons are made of charged particles, so they may be neutral, but they still have a solidity to them, which is a bad word to use in this sense. But neutrons don't pass through each other, for example, partly because their component quarks have different charges, and then those are not completely evenly distributed within the neutron. But there are other things like the strong nuclear force, which you can talk about instead. So there are other reasons why they won't go through each other. Hence how we get neutron stars, so they don't just immediately collapse down to nothing. There are forces. I think that's oh god, I always get this wrong. Oh, that's so annoying. It's gone out of my head. It's one of the exclusion principles anyway that keeps neutrons from collapsing immediately. But they're not like dark matter. Dark matter wouldn't even have strong nuclear force, weak nuclear force. None of the forces, the normal forces. Yeah.
That
dark
is
matter
bizarre.
cannot be operating that way.
And Luke of Paris has posted another comment.
I mean, presumably it must interact with the true Higgs field. Now that's an interesting. Thank you, Luke. They are suggesting, there have been suggestions that it should, if it has mass, which it does, should interact with the Higgs field, but it might not, because the Higgs mechanism is not the only mechanism whereby particles get mass. So it's a possible way we might be able to detect dark matter. Yes, because that might be one inroad we've got. The Higgs field might interact with, very, very cagey here, might interact with dark matter, but it's by no means a surefire bet for getting a detection of dark matter. But thanks, Luke. You did remind me. That's awesome.
And you're reminding me of something from real analysis, which is you can have a set of measure zero with an infinite number of elements, meaning that it's like if you have this bag is full of an infinite amount of stuff, literally infinite, and you look in the bag and you say, I can't see anything. So, well, of course you can't. Literally, if you tried to measure their volume, you'd get zero, but there's an infinite number of them. And people probably go, oh, you're absolutely insane. It's like, well, mathematically it works.
Right.
And that's a result that's existed for 100 years, if not more. There's no question this result is correct. Now, does it transfer the real world? Probably not. But what you're talking about here makes me wonder, I wonder if we've got an infinite set of measure zero here, because who knows? Strange things happen at infinity.
Yeah. I don't know. My favorite answer. I don't know.
I don't know.
Yeah. Yeah. What? Back to dark matter. I think. Hang on, dark matter.
Or dark energy, whichever you prefer.
Yeah, dark energies. If dark energy is, as I like to think about it in my research, a scalar field or more than one scalar field, a bit like the Higgs field, I suppose. That would be that's the first scalar field I think we got that we could actually measure. We didn't know we had. Maybe someone's going to beat me over the head with my ignorance in a second, but I don't think we had a measured scalar field in a particle physics sense until we found the Higgs boson and the Higgs field. Showed the Higgs field was definitely there. So that was great for cosmologists, because at least we knew that if we were imagining dark energy to be a scalar field, or even the cosmological constant that drove inflation at the Big Bang, so the beginning of our universe, could be described as a scalar field. Well, now we have a scalar field, so we can definitely say they are a thing that exists, even if I can't say for sure that that's what the universe was at the beginning, or the underlying mechanism behind accelerated expansion of the universe at late times, which is the dark energy driven stuff we're observing. What about it though? If it's a scalar field, how does it interact? Well, it's interacting, I guess, it's interacting gravitationally as as constant or pseudo constant energy density in Einstein's equation. So it has a relativistic effect of accelerating the expansion of the universe, just as if it was a cosmological constant, which also would do the same thing. But it probably isn't that, because if it was a cosmological constant driving inflation, we never would have left inflation. So we've never had a universe that didn't inflate, which would be bad for the creation of matter and stuff. Anyway, I can't condense the whole of cosmology in 5 seconds. But what was I going to say? Where was I?
Cosmological constant?
Yeah, so that's the thing that drives early inflation. The beginning of our universe. Our universe can be modeled as if it's a scalar field. For dark energy, we can kind of do the same thing. So it's this particle, if you like, that exists in the universe, and its energy density was so low that it wasn't affecting things until the last, oh God, I always get the timescale wrong, 500 million years or billion years, something like that. In the last billion years, dark energy became dominant. So we started to have an accelerated expansion of the universe now, which is a bit like what we had at the beginning for inflation. But this thing acts like a constant energy density and does nothing else, really. It doesn't interact with anything else, at least in the standard models. Of course, the one I've just been talking about, we get it to interact at least with dark matter. Because if the dark sector doesn't interact with normal stuff, there's no reason why it can't technically interact with itself. There you go. That made no sense, did it?
Interesting. Now, the scalar field, is it the real numbers?
Is it scalar? Scalar field would be a real number thing, because it's a bit like just density itself. Density can be described as a quantity that exists without direction, so it doesn't need.
Yeah.
It's not a vector field, for example.
Right.
So yeah, it's pretty basic, but again, it's how is it coupled and how does it interact with other species? That is the question. Does it, in fact, interact with other species beyond the gravitational effect? We're talking about the accelerating effect.
And Luke has an unrelated question. Why do people keep using mildly silly names like black holes and Big Bang for physical entities rather than more appropriate names like dark stars and cosmic expansion? I think the answer there is you have to appeal to the people whose IQ is less than 100.
Yeah, well, the Big Bang thing was as a joke. In fact, it was Fred Hoyle coined the term Big Bang Theory because he was taking the piss out of the theory and he didn't want people to believe it. So he called it Big Bang Theory. It's a Big Bang Theory, isn't it? And unfortunately, it was the one that seemed to work better than any other theory going. Certainly better than his constant generation of matter theory that he was putting as an alternative, that there's just constant matter being generated all the time. That didn't really seem to fit observations in the end. Certainly not when you had when you could. Would that work? Yeah, there were lots of problems with his theory. Basically, Fred Hoyle's theory fell out of favor quite quickly, but he unfortunately coined the term Big Bang for the very thing he was trying to get rid of.
Yep. And then you have a short phrase like Big Bang, just 2 syllables that will catch on in the public imagination, perhaps a bit bigger than cosmic expansion.
Oh yeah, the
5
media
syllables
ran with
does
it
not
really
fit in.
quickly.
Yeah, 5 syllables does not fit in the space for 2, unfortunately.
No.
Dark star is nice. Why that
They
did
do
not catch on, I don't know.
They do sometimes call about they still use the phrase dark stars, but there are a few things that it can be applied to, so it's not exactly universally consistent nomenclature. But yeah, they do sometimes talk about dark stars.
And we do have Hawking radiation around black holes, which means even though they are after the event horizon, they're dark as dark can be. Outside of it, they're producing a lot of energy.
Yes, and cosmic expansion. Well, we do have cosmic expansion. It's just
He's talking about the terms. Why would we use Big Bang instead of cosmic expansion? And
oh, I see. Yeah.
Yeah.
Okay, that makes it linked together. Good. I think.
I suppose, Luke, we could say the answer is not everyone is as intelligent as we are.
Oh, that just sounds wrong.
That's my self-serving answer, and I'm sticking to it.
Thank you. So yeah, I'm sure there's something else. So any other questions?
From me, let's see. Dark matter is just kind of there and interacts with itself, but not other particles. Dark energy, ditto.
Yeah.
And
Different
for whatever
effects.
reason, it didn't start kicking in till 1 billion years ago. And how old is the universe now? Is it 16? Is it 20 billion?
14. It's not exactly. It's maybe 13 point something, but let's go
13
with 14 billion is an easy one to remember.
Okay, so for 13 billion years, the effect of dark energy and dark matter was low enough that things didn't matter. That it didn't matter.
Dark matter's had an effect from the very beginning. That you can see the effects of dark matter imprinted on the cosmic microwave background radiation. That's one of the measures we have for the amount of dark matter in the universe is from that. So that has had an effect because it's stuff. It is. Oh, I always get the proportion wrong, but it's. I think there's 4 or 5 times as much dark matter as there is normal matter, and that amount of stuff was having its gravitational effect on the normal matter as well. Right from the CMB through to now, and it's still, we can measure it in the way that galaxies rotate and continue to rotate without breaking apart.
Let me throw this idea at you. Let's suppose that most of the dark matter and dark energy exist outside of galaxies. And let's suppose it's not actually matter and energy. It's not antimatter in the sense of the traditional definition of antimatter. It is simply the lack of any matter or energy. And that is literally causing a void. And
you mean between the galaxies?
Yes. That it's not being caused by dark matter, dark energy. It's literally the effect of a massive, massive void so thorough that we cannot possibly imagine it.
You wouldn't have galaxies forming the way they are. They wouldn't have the shapes they have now. You wouldn't have any spiral, galaxies, barred spiral, all of that stuff. Nah, it would just mush up completely because they are behaving as if they're embedded in a much larger halo of matter. And it's not that they're surrounded by dark energy.
I see. It's a halo of matter. I get you. Okay, thank you.
Exactly.
See? I had a question. It was answered. Boom. That's science.
And let's go to sleep now. No, I can go on a bit longer. But yeah, that's one I can answer because that is kind of that is my wheelhouse. I kind of should know the basics of cosmology. I do know. I'm an expert. God.
Luke says we got to throw flowers at ourselves just in case nobody else does, which I completely agree with.
Well, on that note, would you like to see my physicist's holiday snaps?
Sure.
So you saw one in the video. I'll just bring up the thingy. Hang on. Yes, it did start there. Okay, so this is where's this? San Vito da Capo. I always get this wrong. It's somewhere not far from Arica, but it's one of the nearest, nicest beaches near Arica. And just remember swimming in there. Beautiful. Look at the sand. It's amazing. And just swim. And yeah, that you might be able to see me. I'm pretty much dead center of this photo, actually. And I obviously didn't take this photo because I'm in it. But by a miracle, I'm dead center. I mean, some of us are striking up silly poses because we'd agreed to strike up silly poses. And I think me and about 2 others are, and everyone else is stood around with their arms on their hands on their hips. And oh, thanks, great.
And who are you pointing at maliciously?
That's Michael Duff, who you saw in the video.
Okay, so what was the reason for threatening him?
Well, it was difficult to see perspective here, but I was actually standing in front of him, and I was striking a silly catalog pose.
Oh, I see.
Yeah.
Looks like you're about to tell him where to stick his 11th dimension.
But it does look like I'm sticking my finger up his nose, but I'm in front of him, all right? But yeah, there's a good bunch of physicists there. There are people like me who are just students. I mean, PhD students, but starting out in their fields, and there were ones there who are much more experienced. And then there are incredibly experienced ones like Michael Duff, who obviously just came along because he thought, "Yeah, I'm going to the beach too. Awesome." Yeah, we had a good time. Physicists are not paid well, but at least they sometimes get sent to nice places for conferences.
Yeah.
And this is one I will always fondly hold these memories with me. The 4 years I got to go there, my supervisor was so pissed off because he'd been a bit tipsy in the bar with me and the friend who's a particle physicist 2 years ahead of me, 1 or 2 years ahead of me. But he already knew, he came from Sicily. He already had inroads into this conference before he got there. And we were sat around at Queen Mary's bar for the lecturers, having a drink with my supervisor and a few others, and he said, "Can he go to Edirol with me?" And my supervisor was a little bit tipsy and said, "Sure, if you can get him paid for, then yeah, you can go," or something along those lines. And so they wrote a recommendation letter to get me in. I had to pay for my flights. In fact, the university paid for it out of my travel fund, but I had to pay for my flights, and then unexpectedly, Eritrea actually paid for everything else. They paid for the food, the accommodation, and I could have been charged for it, but they didn't. And then every year subsequently, which really pissed off my supervisor, they invited me back on full bursary. So they paid for my flights, and they paid for the accommodation, the drink, everything for the next 3 years. Yeah, that actually, this does sound like it has no purpose, but that constitutes funding, bursaries. And actually, it's one of the tick boxes you're supposed to get as you're doing a PhD. Did I get funding for stuff? Yeah, I did. For basically 4 years, I got funding for this conference every single year. So, it wasn't just me going to get free food and booze. I did do things I was supposed to do on my PhD checklist. I did give talks. I gave posters. When you can't give a talk, you could always give a poster. I did everything I could to do the proper academic stuff while there. But everyone comes out the other end with Edirol flu.
What's that?
Well, if you're drinking Masala wine every evening for 10 days, what do you think Edirol flu might be?
Oh dear.
Yeah. It's well known. It had got its own name by that point. Yeah, Edirol flu.
So I thought it would be similar to Miami fever. Have you ever heard of that?
I've heard it. What is Miami fever?
Well, I've not been to Miami, but normally the temperature, the climate is so clement, and there are so many beaches and so many people with boats that if you want, you can go down there and get a minimum wage job, and every weekend you're on the beach drinking or on somebody's boat drinking, and you earn just enough to stay there and keep drinking. And you can spend 20 years doing that and look up and go, oh my gosh, I've just spent 20 years doing this.
Wow.
Yeah,
Wow.
because it's just so nice there. So looking at that beach, I'm like, yeah, that lifestyle of living like that, but not doing too much, I can see how attractive that might be.
Yeah. It was good. I'm very, very glad and very lucky to have been invited to do that. And the other 2 photos, I think they're all Eritrea based ones. Do you want to see the next one?
Sure.
Okay, let's have a look. So look at my spiky short hair. I had only just started the PhD. This was that, I know I talked about the first year. That picture you just saw was actually my second year. So that was 2014. This would have been 2013. The conference always bridged or got very close to, I think every year, it was my birthday always occurred while I was at this conference as well. So.
Do I have to say it?
Go on.
Bow ties are cool.
Yes, you do. Although I got mocked mercilessly for bringing this amount of gear to wear for the first dinner. I didn't dress ever again as nicely as this. I've been told that you should dress nicely for the conference dinner, but this was over the top, so I never dressed like this again. But my God, that first year I met Michael Duff. Trying not to geek out on the taxi to the conference center. This is 2013, around July the 4th. That's my birthday. What happened in 2012 on July the 4th? Do you know?
No, I can't remember back that far.
That was when they discovered the Higgs boson.
Oh, that's right.
On my birthday.
Oh,
in the
nice.
year when I'd already decided to start doing a PhD, but hadn't started because it was July and the PhD didn't start till September, October. So Higgs boson was discovered. And within the year, so before this photo was taken, somebody got a Nobel Prize for that.
Nice.
Who do you think got the Nobel Prize for the Higgs boson?
Tell me.
Well, Peter Higgs.
There you go.
Because he was still alive. Is still alive, I hope. I haven't checked in a while. I hope he's still alive. So anyway, and as I kind of already said, this conference was mostly particle physicists with some hangers-on like me attached to the side. So this is my geeky. So we had the Michael Duff try not to geek out, going, "I saw you on Horizon." This is me attempting to not get in the queue for photographs with this other guest at the conference who was there. But in the end, I thought, "Oh, sod it, once in a lifetime opportunity." So this is my photograph with Peter Higgs, Nobel Prize-winning Peter Higgs.
There's two people in the photo. You'll have to help me out.
So the one on the left is Peter Higgs.
Okay.
The one in the middle is me.
Yeah, that.
And the one on the right is Alan Walker, who always used to go with him as a sort of minder from the, I think it's Edinburgh University, and they used to send Alan Walker. Peter Higgs is a very quiet, modest, shy almost guy, whereas Alan Walker was much more an upbeat guy. So he's kind of like the PR wing of Peter Higgs.
Interesting.
So yeah, I did learn up for the photograph, and then they decided to put me on the same table as them for the conference dinner immediately afterwards. So I ended up spending the entire evening talking to Alan Walker, actually, because he did all the talking. And I think the most that Peter Higgs ever said was, "Can you pass the bread rolls?" Like, yes, I can. I can do this. And then the rest of the time talking to Alan Walker. But yeah, I got to have dinner in this one conference, this first conference I went to virtually. Dinner with taxi with Michael Duff, dinner with Peter Higgs, who had just announced his winning of the Nobel Prize thing within weeks or months of him arriving. So I was so lucky. I mean, so many things happened to fall. I had actually a really crappy time in 2012 up to that point for various reasons. I don't want to bore or labor or burden the chat with the crap that had happened to me, and I was still dealing with a lot of crap even at this point. But I was so fortunate to being allowed on the PhD course at a time when the physics world was bustling with news of the Higgs boson, and to meet Peter Higgs and to just I will never regret my decision to do these things. And I would recommend. Go on, sorry.
No, excellent. I was just saying that's excellent.
I was very, very lucky to be able to do these things and meet these people. And I do have one more slide. Do you want to see the other slide?
Last slide.
Okay, last slide. So it's all people I have met, basically. There's me again. But so the guy handing me the prize there is Gerard. I always get his name wrong. Gerard Toft. Toft. Do you know the name?
I'm afraid not.
I wouldn't expect it because many of these people are. I mean, Higgs is famous. You had heard of Higgs, yeah?
Oh, definitely, yes.
Yeah. Toft should be famous. He is famous in physics. He's famous for his work on quarks and the color properties of quarks. Essentially, they're charges, if you like, they're color charges. And he won the Nobel Prize in '99 for his work on quarks and their properties. So that's Nobel Prize winning Gerard Toft. I can't pronounce his name. It's obviously Dutch, and I have trouble with it. But Gerard Toft, and we had long conversations at various points about my research, and I'm sure I said everything wrong to him, but fortunately he wasn't working in my field, so I got away with it. But that's always get out of jail free card. He's not working in my field. I can say anything I like. I was a bit drunk at the time as well. Anyway, but yeah, I won a prize.
Nice. What was the prize for?
They had a large number of new talents prizes, which were for people new to the field of physics who were doing research. And I don't know, there must be about 30 of those given away to the 150 people there. So it's a small but not insignificant proportion could win prizes for if their talks were a sufficient level and interesting enough. Yeah. And I have no idea how they decided these things, but thankfully, this is, I think, second talk or third talk I've given there. This was 2015, so this is the penultimate year I went there, and I had given posters and or talks on every occasion that I've been there. So maybe it's just for contributing, showing willingness. So maybe it was a wooden spoon. I don't know, but I got a prize, so I'm officially a prize-winning physicist.
Nice.
And I got my prize from someone who actually won a proper prize, a Nobel Prize from a Nobel Prize-winning physicist.
Wow.
Yeah, that's my high
great.
point. It was downhill from there.
Oh, well, it's nice you had a high point.
Yes, I will never regret this. I mean, yeah, no matter how annoyed my supervisor was, I'm glad I went back to this conference repeatedly.
Yeah, definitely.
Let's remove the embarrassing photograph of me and my profile.
Well, we're getting to 15 minutes.
Oh no! I removed you instead of the picture.
Let's get rid of that annoying thing, shall we? Boom! I disappear.
It was definitely a Freudian slip.
I don't need a bloody co-host. Get off my channel. Oh, that's hilarious.
God. Oh wow! I haven't looked at the chat in ages. Luke's probably just fallen asleep or run away. Awesome photos. He's still there. Thank you, Luke.
I think the billionaires have been funding massive amounts of scientific research, and they're just not publishing it. I think they're looking into all sorts of things about how they might better control and take away what little we have to make sure they get more, because the need for some people just to own everything is insatiable. It's very, very sad.
Do you think the billionaires own physicists then?
Oh, definitely. I talked to somebody who was in the corporate world enough to say, yes, they buy the government gets the PhDs that these billionaires don't want. Now, is this 100% true? Well, I can't verify it personally. Do I think it's got a grain of truth? Oh, yeah, definitely a grain of truth.
Well, there's definitely, for example, money behind that conference I was just talking about. We're not getting massive amounts of money for it, but it's not nothing to set up something like that.
Right.
So, and I'm not going to, I don't want to say too much, but I know something of where the money for that conference came from. And yeah, it was via a physicist, but that's not all he is. So that's all I'm going to say. Yeah.
Right.
Well,
we all imagine if we were the billionaires, we would be the ones who would be as ethical as Bruce Wayne, even though we're not as athletic. And the fact is, we would face the same pressures they do, which is, I want this thing. This guy's being unreasonable. I'm going to have it. It's just how human beings work. Unfortunately, it doesn't get better the more money you have.
No. Very true.
But it looks like we're about 15 minutes past the hour.
Thank you. That's what I was going to ask. How long have we been yammering on for? And should we bail now?
We probably should bail. I don't think we can top your photographs.
Well, at least I guess we ended on the right thing then, yeah? So
oh, yeah, definitely.
My holiday snaps. Here you go.
This is Uncle Ted in front of the house.
Exactly. So yeah, I guess I should end the stream then, unless anyone in the chat suddenly leaps in and has something of amazing import they want answering. You've got, I don't know, 5 seconds to get our attention before I leap forward inelegantly towards the laptop, slap my face there, and then attempt to end the broadcast in one swift swipe of my finger, which never works. And hopefully not just to eradicate old media guy. I can hear nothing in the chat. I see nothing in the chat. Going once, going twice. All right, I'm going towards the stream. So I'm going to end the stream, except, old media guys, anything you want to plug for yourself?
I just came out with a funny Star Wars video on Friday, and it's only got 30 odd views. So if you would like to head over there and take a look at it, that'd be great.
I will definitely do that too, because I've definitely not seen the funny Star Wars one. What's the name of that video?
That's a good question. It deserves a good answer.
Hoping you knew the answer to it.
I got to look up my own channel because I have forgotten the name of my own video. It is Star Wars, Disney's Final Edit. Who shot first?
That one, right? I'm going to watch that immediately after the stream. That's my homework.
Okay.
Oh, and as for next week, well, we already discussed there were 3 potential ones I was going to watch, so I think I know which one I'll grab for next week. So
Okay.
don't need to bother about that. It'll be fine. And again, I'm sorry to everyone that I have to mess around with the video and audio and the speed and everything. But this is the only way I can get what was once public domain, publicly made public broadcast stuff viewable to the public now.
Yeah. I'm glad you're doing it.
Thank you. And on that note, I'm going to run towards the laptop. Here we go. Ah!
And away I go.